Alright, today we are going to be looking at inequalities, like less than or greater than, and how a variable can represent things other than just one single number. So if you look at the first line, it says a variable does not always have to be blank to one single number. It does not always have to be equal to one single number. So it can be equal to more than one. So 2 numbers, 3 numbers, 4 numbers, or an infinite amount of numbers. So the second line, a variable can be equal to all numbers less than or greater than a number. It can be equal to all numbers greater than 5 or all numbers less than -2. Okay, a wide range, and whenever we see that, that's an infinite number because all the numbers greater than 5 go on and on forever, and all the numbers less than -2, they go on and on forever in the negative direction. So when we look at these signs, if we're going to actually write out what they say in words, we're reading it from left to right. So if there was a number here, that number is something compared to another number. Now we talked about the less than or greater than. When we did our absolute value stuff, it's always open towards the bigger number. So something is less than something else. It looks like this because if the number was here as I read it left to right, it's close towards that number, so it makes the number on the right bigger. So this number is less than that one. Now when I add the little line underneath, that's less than or equal to. So the little extra line means it's not just less than, it also includes the number. So it could be 4, or it could be all the numbers less than 4. Now when I flip it the other way, if I was reading it from left to right, some number, it's open towards that number, so that number's bigger than whatever's on the right. So that is greater than. And then this still says greater than, but it also adds the little line. So this is greater than or equal to. Quick review. We've already talked about that. So number 1, if I'm going to write this inequality out in words and then also put it on the graph starting with words, K is, it's open towards the K, so greater than -5. Now what does this look like on the graph? So what we're going to do is we're going to put a circle at -5. So it's not actually going to be around the number, it's the point on the graph that represents -5. So it's going to look just like that. Shouldn't be above it, below it, right on the number, right on the graph. So not around the -5 right there. We're not going to fill it in. Okay, if we filled it in, it says it's equal to -5. But if K is greater than -5, it means all the numbers that are greater than. So positives are always greater. Plus -4, -3, -2, -1, those are also greater than -5. Anything to the right on the graph is greater than. So what we're going to do is we're going to shade it in. So you're just going to shade it. Now you're not going to draw a line above it or below it. You're going to shade in the line. Now if all I did was shade this, then my answers only go from -5 to 7. But there's other numbers past 7 that are greater than -5, and so they're part of this solution set. So we need to show that even though the graph ends, the numbers that would continue on if we continue the graph, since they're also in the solution set, I need to put an arrow showing that they are also part of the solution. So we're not filling it in because -5 is not part of the answer. K is not equal to -5, it's greater than. So -5 is not part of it, it's open, but everything greater than -5 is part of the solution set, including stuff that's not on the graph, so I'm going to put the arrow. So number 2, if I write this out in words, A is less than or equal to, it's got the line underneath, so less than or equal to 6. So to put this on the graph, I go to 6. And now I'm going to fill it in. Okay, so right here this says A is equal to 6. If I don't do anything else, right now it says A is equal to 6. It's filled in, so that means 6 is the solution. A is equal to 6. So far that's correct because A is either less than or equal to 6. But we didn't put the less than part. Right now we just have equal to 6. So all the numbers less than 6 are this direction, all the negatives plus 0, 1, 2, 3, 4, 5. Also the fractions and the decimals that are in there. And we need to put an arrow because all those other negative numbers that continue on, they're also less than 6. So they are part of the solution set. So we need an arrow. Okay, number 3. 3 is written out kind of backwards. Okay, it's the number and then the letter. Now we always read this in terms of the letter. So what we need to do is, first things first, we need to flip this. So I need the n on the left and I need the 3 on the right, and we're always going to do that. We want it written in terms of the letter. The letter of the variable is something compared to 3. Now if I go to the original, it was closed towards the n and open towards the 3. So if I rearrange this, it still needs to say the same thing, which means this needs to continue to be open towards 3. So I'm basically just flipping the whole thing, which means the sign also needs to flip. So it was closed towards the n, it's going to be closed towards the n. So now what does this say? This says n is less than 3. And that's how you need to write it out. So we're not going to say 3 is greater than n. That's true. Okay, but we want it in terms of the letter, not the number. So we want to know n is something compared to the number. So n is less than 3, so I'm going to go to 3. I'm going to put a big open circle because it's not equal to 3, it's just less than. So all the numbers less than 3. Is 0 less than 3? Yes. Is -4 less than 3? Yes. That's why they're in the shaded region. Is 6 less than 3? No. That's why it's not in the shaded region. So the shaded region represents the letter. So all of this, including what's not written, is n. All of those are the values of n. So number 4, first thing I'm going to do is I'm going to rewrite it. So I'm going to put the m in front, which means I need to flip this sign. It needs to stay open towards the m, -5. So what does this say? M is, it's open towards the m's. That means m is the bigger number, so it's greater than. It's also got that little line underneath, so it could also be equal to -5. Put it on the graph. Go to -5. It could be equal to -5, so we need to fill it in. -5 is part of the answer. Plus all the numbers greater than -5. So it's kind of easy if you think about it. If you got a negative and you're talking about all the numbers greater than any negative, it's going to include positives. So if you're confused on which way to shade, it's a negative. Think about the numbers that are greater than a negative. Well, that's all the positives. Now there are some negatives that are greater than it, but the positives we know are greater than negatives, so could just go that direction. All right, number 5, now they give you the graph and they want you to write the inequality and write the sentence. We're actually going to start with the words first. Now you can use any letter you want. I'm just going to use x because it's what we're used to. So I'm going to say x is. Now based on this graph, I see a filled in circle, which means it could be equal to 6. Plus I see it going to the right towards 7, 8, 9, 10. Those numbers are greater than 6. And remember, the shaded part represents the letter. So the shaded part is x. So x is greater than, or, I almost forgot it, or equal to 6. So x is greater than or equal to, since it's filled in. Let's just kind of clean that up. Or equal to 6. Now it says write an inequality and write it out in words. So we did the words. What does the inequality look like? It looks like this. Okay, so how do we write it out in symbols basically? So x is greater than or equal to, x is greater than or equal to 6. All right, number 6 now, rolling on to that. Not included, so I'm not going to have an equals to. The shaded part represents x is going down towards the negatives, which means x, all these values are less than -3. So how would I write this out in symbols? Start with your variable, x is. Less than means it's pointing away. -3. All right, now we're going to jump into looking at how do I solve bigger inequalities, there's more steps, more stuff going on. So right now this says 3 times a number plus 3 is always less than 48. So there's lots of different answers that could be true here. Think about 0. 3 times 0, 0. Plus 3 is 3. So is 3 less than 48? Yeah, so 0 is a possible answer here. Think about 10. 3 times 10 is 30. Plus 3 is 33. Is 33 less than 48? Yes. So 10 is a possible answer. Think about 100. 100 times 3 is 300. Plus 3 is 303. Is 303 less than 48? No. So that's not a possible answer. So there's a dividing line somewhere, okay, in between those numbers. So we need to find it. So instead of working through our graph, because if we're going to start showing work like we're used to, right underneath on both sides and all that stuff, we don't want to go through our graph. So I'm going to ask you to just rewrite each one underneath so you can work. If I could reformat this to put the graph on top, I would, but this program's not going to let me do that. So just translate this down, rewrite it, and now we're going to show our work the way that we're used to showing it. So treat this like an equal sign. That's your dividing line. You want to get that b by itself. So I want it to say b is less than something. So try and get b by itself here. We're going to minus 3 on both sides, just like we're used to doing. That's going to leave me 3b. These cancel. And 48 minus 3 is 45. So 3 times something is less than 45. I'm going to get rid of the times by dividing. These cancel. 45 divided by 3 is 15. You can use a calculator. So my final answer is b is less than 15. So any number that I plug in that's less than 15 is going to make this true. Any number more than 15 is not going to make this true. And 15 itself is not going to work either because it's not equal to. So let's put this on the graph. 15, open circle because it's not included, less than 15. Looks like this. Let's try number 8. Bring it down. Okay, I'm going to add 5 to both sides, leaving me just x over 2 and 5. To get x by itself, I'm going to times by 2, and I get 10 and x. Notice I never flipped the sign. Now, I don't want to leave my answer like this. I want x in front, so I'm going to change it. I'm going to put x first. I'm going to flip this. It's open towards x. It needs to stay open towards x. And 10. So if you ever get an answer that's not in proper form, put the x in front and flip it. I'm going to put this on the graph, go to 10, put a circle. It could be equal to 10, so I'm going to fill it in. And then everything greater than is this direction. Okay, the last two have one special thing we need to keep in mind. So on these two, you're going to need to flip the inequality when you multiply or divide by a negative. So for the sake of time, I'm going to just put the work straight up without writing it out. So you can pause the video if you need to catch up on the work. Pause it, write everything down, and then go back and listen. But when we get to our last step, when we're dividing here or multiplying here, if it's a negative number, we need to flip this. So I'm going to show you what that looks like. So I'm going to flash the work up here. If you need to pause the video just to copy down the work, go ahead and pause it. And then you can restart it and listen to what I have to say. So when I do all this work, it all looks the same, minus 3 on both sides, and now I'm dividing on both sides, but I'm dividing by a negative. Okay, so this is the spot we need to really be careful of. I'm dividing by a negative number. Notice what happened to this. N is by itself, but this less than became a greater than. Over here, minus 1 on both sides, divided by a negative. Okay, so this sign needed to flip, and you can see I almost forgot to do it. I almost left it the way it was. I almost left it open towards the B, but it needs to flip. And if you test these numbers out, okay, 0 should not be part of this set, right? So I plug in 0. Negative 4 times 0, 0, plus 3, is that less than negative 5? Is 3 less than negative 5? No, so it shouldn't be part of the set, so you can see 0 wouldn't work, and these numbers will. Okay, so we'll talk a little bit more about why that needs to happen, but this is the big thing you need to get out of this. Okay, on that last step, if the number you're dividing by is negative, okay, you need to flip this sign.